Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 18 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 679, 24 game. And this question is asked in Google as well. So now let's read the problem statement. You are given an integer array cards of length 4. You have 4 cards, each containing a number in the range 1 to 9. You should arrange the numbers on these cards in a mathematical expression using the operators plus, minus, multiplication and divide and the parenthesis to get the value 24. Right. You are restricted with the following rules. Rule number 1. The division operator represents real division, not integer division. For example, 4 divided by 1 minus 2 divided by 3 is equal to 4 divided by 1 divided by 3 is equal to 12. Right. Here, why I'm saying this is nothing but a real division. Okay. So here see 4 and then after that divide by, and here 1 minus 2 divided by 3, right? It is like this. So here 2 divided by 3, so if you are going to do the integer division, so 2 divided by 3 you are going to say that it is nothing but 0 only, right? So here your denominator is going to look like this, 1 minus 0 1, then your output is going to be 4 only, right? If you do integer division. But now if you do real division, so how you are going to solve it? So 2 divided by 3, it is going to give you some value in double format, right? So here if I just solve it like this, let's say if I pick this part only, so I can write it like this as well now, 3 minus 2 and divided by 3. I can write it like this, right? 3 goes here, 3 minus 2 divided by 3, and this is nothing but 1 by 3, right? Clear? Overall this is nothing but 1 by 3. So 4 divided by 1 by 3, so 1 by 3. So here if you do integer division of just 1 by 3, so you are going to say that this is nothing but 0. 4 divided by 0 if you do the integer division, right? Here 1 divided by 3, so you are going to say now that if I'm going to do the integer division of this is nothing but 0. But no, this is not 0, right? 4 divided by 0, this is not right, right? So if we have to do the real division, that simply means 4 divided by 1 by 3. So 4 divided by 1 and 1 divided by 3, 3 goes up here. 3 into 4, 12, 12 by 1, 12. So that is why 12 is coming, right? So now let's discuss this point in detail here. So division is a real division, not integer division. In Java, C++, if you do 5 divided by 2 with integers, you normally get 2, right? Integer division, right? But here we must treat this as real division. That is 5 divided by 2 is nothing but 2.5, not 2 but 2.5. Same way here 4 1 minus 2 by 3, so this is nothing but 4 1 minus 0.666, and this is nothing but 4 divided by 0.33, that is another 12. So since we are getting values like this 0.666 0.333, so I am planning to use double in my code. Okay, so this is the reason I'm going to use double in my code. All right, so this is one point. So even if the card numbers are given to me as 4187, so I'm going to write them as 4.0 1.0 8.0 7.0 because I have to do the real division, right? So I will get values like this 0.666. That's why what is the first thing that I'm going to do? I'm going to make these cards in double, right? The int cards, right? Int type, I'm going to change it to double, right? Okay, this is one thing here. All right, now after that every operation done is between two numbers. In particular, we can't use minus as a unary operator, right? So for example, if you have cards like this 1 1 1 1, so you can't use minus in front of them, right? You can't use minus in front of them. Like let's suppose this number, you can't use minus in front of this. You can only apply the operators in between two numbers, right? Let's discuss this point in detail now. every operation is between two numbers. You can't use operators like a unary, minus, negation. So example, this is not allowed, -1 -1 -1 -1, because the first -1 is a unary operator applied to one number, right? So allowed operations are always between two numbers, like 8, and here I'm using minus, here I'm using multiply between two numbers, here I'm using divide between two numbers, right? So this is the second point. Third point is you cannot concatenate numbers together, right? For example, if cards are 1 2 1 2, so you are not going to write them as 1 2 1 2 to get 24. No, this is not valid. So here you can't concatenate digits, you can't join two numbers together to form a bigger one. Example, if the cards are 1 2 1 2, you can't say 12 plus 12 is equal to 24. Each card must be used as an individual number, not must. Okay, so this is done, right? So here we have to return true if you can get such expression that evaluates to 24, right? So somehow we have to make 24, and otherwise we have to return false. Okay, so this is the problem statement for this one. All right, and here before proceeding further, one more thing. Here if I write, let's say double x is equal to 0.1 plus 0.2, right? And here let's say system dot out dot print ln, and here I'm printing the value of x. Tell me what is the output for this one, this for this line. And let's say here I'm just returning true or false. I just want to make my code run, right? So tell me the output of this one. Is it going to be 0.3 or no? So now let's run it, let's see. So see, this is my output from where this 4 is coming, right? So since I'm using double, right, even if I'm doing the addition, I'm seeing some changes here, 0.3, and here I'm seeing 4, right? This should not be there, right? So here we have to return the true if you can get such expression that evaluates to 24. All right, so here what I'm going to do, even if I get my output like this 23.9999 something like this, I will say that this is 24 only approx, because I'm doing the divisions, right, real divisions. So there might be slight changes in the output, there might be slight changes in the output. So if I'm getting this, I will say that okay, no issues. If I'm getting something like this 0 0 0 0 1, okay, something like this, then also I will say this is nothing but 24 only, very close to 24, right? But this 25 is not close to 24, right? This is not equal to 24, right? So here let's discuss this point now. All right, okay, so here this, so if numbers are large, use a bigger tolerance like 1e minus 3, that is nothing but 10 to the power minus 3, or you can say 0.001. okay, this much difference, maybe number is this much bigger or this much smaller. If numbers are small and require high precision, use a smaller tolerance like 10 to the power minus 9. For this particular problem, LeetCode 24 game, you can use this as well. 1e minus 6 is the sweet spot and is also the value most official editorial solutions use, right? So you can try this. You can say that this much difference, okay, or 0.000001, right? So you can say this much value bigger or this much value smaller. You can use this 1e minus 6, you can try to use 1e minus 7, you can try to use 1e minus 8, you can try to use 1e minus 9, you can try to use 1e minus 3, 1e minus 2, 1e minus 1, you can try all, right? We just need to make sure that all the test cases has been passed. Okay, we have to just make sure that our solution is accepted, right? So we'll try this 1e minus 6. okay, you can also try this. I think with the 1e minus 2 also we are able to pass all the test cases, or 1e minus 9 also I think we are able to pass all the test cases in this problem. So but we will use this 1e minus 6 because most of the editorial solutions are using this, right? So in the 24 game problem, numbers are small, 1 to 9 integers, and we repeatedly do addition, subtraction, multiplication, division, like 1 by 3 is 0.333, right? introduces rounding, right? So after many operations you may accumulate tiny errors, right? So choosing 1e minus 6 allows some wiggle room for those errors while still being strict enough to avoid falsely accepting wrong results, right? Okay, so this I have already shown you, right? Floating point numbers like double in Java are not always exact after arithmetic. So here if you do this, you are getting something like this, not 0.3, but you're going to get something like this. It is not exactly 0.3 but very close, right? So instead of checking that my number, so number is just equal to 24, which could fail due to tiny precision errors, we are going to check num.get minus 24, and whatever the difference, okay, it should be less than 1e minus 6 or 10 to the power minus 6, right? So that means if the value is this or this, we consider it equal to 24 only, right? And here I'm taking the absolute, right? So difference should be less than this. So here 1e minus 6, you can try 1e minus 1, 1e minus 9, you can try 1e minus 9, any value, right? So we just need to make sure that our solution is accepted, right? So if you don't try this now, so there is one test case which is getting failed if you don't use this 1e minus anything, okay? If you just use 0, right? So you're not going to get exact 24 in one of the test case. I think I will show you in the end. All right, so here, okay, so here didn't take any example, so let's take this example 4187. Okay, so here let me just copy this example, 418 and 7, right? So here we have numbers like this, let's say this is my 4, this is 1, this is 8, and this is 7. All right, okay, so here what I'm going to do, I have to pick two numbers. Let's say I pick this and I pick this, right? These are the two numbers that I pick first, right? So in these two numbers I have to apply some operations, right? So I maybe I can do 4 plus 8, which is nothing but 12. This is what I can do. Or I can do this 4 minus 8, 4 minus 8 among these two numbers, so I will get minus 4. Or I can do 8 minus 4, so then what I will get, then I will get 4, right? Or I can do one thing, I can multiply these two numbers directly. These are the operations that I can apply on these two numbers, right? Pick any two numbers and apply the operations. Okay, then what else, we can also apply divide, right? Okay, so here 4 divided by 8 we can apply. So what I'm going to get, 0.5, right? And if I do 8 divided by 4, then what I will get, I will get 2, right? So all these things I can get from here, right? All these things I can get from here. All right, so now let's suppose from here, let's suppose if I try to use 12 first. So from here, the next number that I'm going to get here, I'm saying next is nothing but a 12. Okay, from here I'm driving 12 next, let's say next, and from here 1 comes, and from here 7 comes. Now among these three I have to do the same operation, so I have to pick any two numbers, and then again I have to start the all this process. Okay, I have to start building the tree like this until I get one single number in the end, right? Now let's suppose in the end I didn't get the number which is very close to 24, okay, which is equal to 24 or very close to 24. So what then I have to traverse back, then I have to traverse back from here. Then because here I with 12 I check the result, 12, 1 and 7, using 12, 1 and 7 I check the result. So in the end I added 12, right? 1 I have, 7 I have, and 4 and 8 result is 12, and then I add 12 here in this stage, okay, in this stage. So now with this 12, 1 and 7, let's say I didn't get the result equal to 24. Now I have to do backtracking from here, so I am going to do backtracking here. All right, so in backtracking, when I'm going to do the backtracking, last time I have added this 12, so now with 12 answer not possible, so let's say I want to use something else. Maybe instead of plus, maybe I did this step. Okay, maybe I did this step, so let's use this 4. All right, so now you are using this 4. Now among these, let's suppose you pick this number and this number. So in this 1 and 7 you can do many operations, right? You can do subtraction, multiplication. So let's say you did this 7 minus 1, which is equal to 6. So from this and here, which is the remaining part is 4, and from here you are adding new part. Okay, so 7 minus 1, let's say you added 6. So now from here also you are going to get multiple results, 4 minus 6, addition, subtraction, right? So in the end, if you see, when you do 4 into 6, you are going to get 24. So if you get 24 now, just simply return true. If you are not getting 24, so you have to do the backtrack. So in backtracking, last time here 1 6 output you have added 6 now. So with this 6 also, let's say output is not possible, so you are going to remove this element from the next and add some other element. Okay, maybe 1 into 7 you added 7, and then again you have to proceed. So this is nothing but backtracking that I'm doing here, right? So here if you read this, you have 4 numbers and you may insert binary operators and parentheses. Any valid expression is a binary tree with the 4 numbers as leaves and operations at internal nodes. Repeatedly picking 2 numbers, applying an operator and replacing them with the result is same as building that expression tree bottom up, right? The algorithm treat the cards as doubles, and you already know why I'm treating the card as double, because we are doing the division, real division, right? If there's one number left, check if it is approximately equal to 24. Otherwise, pick two numbers a and b, try every possible result from a and b, like a plus b, a minus b, b minus a into b, a divided by b, b divided by a. Produce a new list with that result replacing a and b and recurse. If any branch reaches 24, return true. Because we try all pairs, all operator choices, and all orders, we cover every parenthesization and operator assignment. Okay, so this is what we need to do. We have to do backtracking to solve this problem, right? So now let's write the code and let's understand step by step. Okay, so here first let me just remove it, right? This is just for showing that we may get slight deviations in the original result, right? So 23.9999 or 24.00001, like that. Okay, so here first thing, we have to convert these card numbers to double, right? Because I have to do the real division. So what I'm going to do, first I'm going to create one array list. So list, and here double nums is equal to new array list. Done. And then after that I'm going to iterate over all the cards one by one. Int c in cards, and here inside this I'm just going to do nums dot add, and here I have to change them to double, right? So double, and here I'm just going to write c. Done. And from here I'm just going to simply return, I'm going to call backtrack. I will apply the backtrack on this nums, right? I will write the method for this now. Backtrack on this nums. This is done. So this is the first step that we need to do. So I did nothing here, just whatever the cards I have in int type, I just change them to double, and after changing them to double, I have added them to one array list, and I use this array list nums and I call this method backtrack. All right, this is done. So this is done here. Now here we have to generate the possible results from two numbers. So that method is also going to be very simple. Let's say private list, and in a list what I'm passing double only, right? Double, and here compute method. So let's say I'm passing two numbers. So one is double a and one is double b, right? So inside this from this method I'm returning a list, and that list is going to store all the outputs, right? 12, -4, 4, 32 of two numbers. I will store everything here. So what I will say here, let's create one array list result in which I'm going to store all these values. So list double, and here result is equal to new
array list, and this is done. And now here in the result I have to add a plus b. It's a very good question, right? Result, in the result I'm going to add b plus a. I don't need to write because a plus b is equal to b plus a. So here a minus b I have to write, and a minus b and b minus a definitely will get different output side. So here I have to add this b minus a also. This is what I need to calculate. I will add the answer of this one as well. And a into b and b into a also I don't need to write because a into b is equal to b into a. Okay, then after that a divided by b and b divided by a, I have to get the output of these two as well. But I have to make sure that if I'm doing a divided by b, so my b should not be equal to 0, right? But there may be some slight deviation in the value of b. It may be 0.00000 and 576, something like that. It is may not be exactly equal to 0. So I will allow little bit deviation because I'm going to do real divisions, right? Here I think in one of the example I see that here yes, 2 divided by 3. So here, okay, this is also not equal to right. But here, okay, and yeah, here, right, this example 0.333. So I'm not going to treat this as 0, right? So 4 divided by 0.333, I'm not going to treat this as 0. So here, that's what I'm saying, right? So here this is equal to 12. So here I will allow this 0.33, then I should divide. So here what I will say, if math dot absolute of b, right, absolute of b, if it is greater than, let's say, 1 10 to the power minus 6, right, 1e minus 6, so I will then do the division. Okay, but if it is like 0.00001, then I will just consider it as let's say 0 equal to 0. But if that's not the case, then if that's not the case, then I have to use this. So in the result I'm going to add a divided by b. All right, and same way, if math dot absolute of a value is greater than 1e minus 6, then in the result I'm going to add what, b divided by a. So I hope until now everything is clear. This is the basic thing. We did nothing here, very simple, right? All right, so this is done. Now the main part, that is this method backtrack. All right, so now let's write the code for this. Private boolean, and here backtrack, and inside this I'm just going to pass this list, array list. Copy this and pass this. Okay, so this is done. Now here when I have to check my final result, when out of 4 cards, if I do any operations, only one number is left, right? After doing operations like this 8 minus 4, 7 minus 1, all this stuff, if only one digit remains, right? So here from this, now here 3 digit remains, then 2 digit remains, then in the end there will be one time when only one digit will remain. I have to check this number only. So here what I'm going to check, if nums dot size, right, if nums dot size is equal to 1, this is the base case, then I will return true. If math dot absolute, I will allow slight difference. So here nums dot get of 0, okay, this value at 0 index, if I subtract 24 from it, and absolute of this, it should be less than 10 to the power minus 6, or I can write 1e minus 6, right? So if this is the case, then I'm going to return true. That's it. Okay, so this is done. Now this is the base. Now after that, what I need to do, so here first n is equal to, what is the size of my list? Okay, nums dot size, I'm calculating that size. Now I have to pick 2 numbers every time, right? Pick 2 numbers. So how I'm going to pick that? So for int I is equal to 0, I is less than n I plus plus, and here one more loop for int j is equal to 0, j is less than n, and j plus plus, and I need to make sure that these two numbers should not be equal to, both are same, right? If I is equal to j, both are at same index, then I don't need to pick that. Then in that case just continue. So now I am picking two numbers, right? I have picked two numbers. Now I'm going to create one array list next. So in that next array list, so let's say I pick this 4 and 8. So in the next I will add the remaining portions. Okay, I have picked, let's say, this 4 and 8. Now remaining is this 1 and 7. I'm going to add these remaining in my next array list, right? So here I'm going to create one more array list double next is equal to new array list. This is done, and now after that we have to pick the remaining numbers, right? So int k is equal to 0, k is less than n, k plus plus, and here after that, here I will just write if k is not equal to I and k is not equal to j. In that case you have to add the number in the next. So next dot add, and here nums dot get k, right? So this is what you need to write here. This is done. All right, so I hope that until now everything is clear. So now once this is done, once this is done, right, now after that I have to apply the result on the remaining numbers 1, 7, and the output that I'm going to get from this 4 and 8. Here these numbers I have already added in next, and this number I have to add in next one by one. So maybe first time I will add 12, then 4, then minus 4, then 32, then 0 0.5, then 2. Okay, like this. So for each loop I'm going to use for double and val. So first let's compute the output of this I and j, two numbers I'm passing now here. So I'm going to write compute, and I'm going to get some result here. So nums dot get I, this is what I'm passing, and here nums dot get, and here I am passing what, j. These two numbers I'm passing, right? So inside this I'm calling this compute, and in compute I'm returning this result. Okay, so I will iterate over all these numbers 12, 4, minus 4, 4, 32, right? So first let's say I place 12 and 1 and 7, right? So on this I have to do the backtracking now. So first thing, remaining is 1 and 7, and in the next also add this 12 first, then minus 4. First add, let's say, this 12 I have added. So what I'm going to do, next dot add, I'm going to add one by one, right? First let's say I have added first value. First I will add this, then with this I will check out the possibilities, then I will add this, then with this I will check the possibilities. Okay, so now once I add this, so now again from this again call the backtracking, this method, backtrack method. So in backtrack what we are passing, we are passing the array list nums, right? But this time just pass this array list next, and my next contains 12, 1 and 7, let's say, or 4, 1 and 7, or minus 4, 1 and 7, right? So here I'm going to call this back, and I'm using here if condition as well, if backtrack, and in backtrack I'm passing next, right? If backtrack of next, right, if it gives true, then just return true, right? Otherwise, okay, if with this answer is not possible, so last time let's say I have added 12, so now instead of 12 let's add 4, and with 4 check the possibilities, right? So next, from this next remove but the last element that we have added. So next dot size minus 1. So this is how we write the code for backtrack. Okay, backtrack. All right, and this is done. And if we are not able to return true, right, anywhere, then in that case here I'm just going to simply return false. That's it. Now let's run the code and see if there are any code issues. So yes, illegal start of expression, private boolean backtrack this. All right, so let's fix this. what is happening, this is one for loop, and in the for loop I am going to add all this. So why I'm writing it here, let's write it here. Okay, this one here, and then this. Okay, and this we need to remove, right? And this ends here, and then I'm going to call this here. Okay, and this is ending here, and then this I'm calling, this is ending here, this one is not required here. And now let me format the code. So now it looks like this. Now let's run it. Right, so now see, all the test cases has been accepted. Right, now if I submit it, so see, our solution is accepted. Right, okay, so now if I don't use this, let's say if instead of this I write is equal to 0, then if I submit it, then you will see that in one of the test case will fail. So see, 70 out of 71 test cases passed, and this is getting failed. Right, so this is what happens when we are using double. Right, so here use this. Okay, this is done. Right, now let's submit it. So I have changed it back to this. Right, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.